Hey guys, welcome to this video on Python programming language and on machine learning. So in this video, we're going to actually do something pretty amazing, pretty cool. We're going to try to predict stock prices. So right now I'm currently on Google's website called colab.research.google.com. And the reason why I'm on this website is because it makes it really easy to get started with programming in Python. So you do not have to download the programming language, the Python programming language, onto your computer. All you need is a Google account and a browser, and you just go to this website here, and I put the URL in the description below, and then you can get started right away with programming in Python. So let's go ahead and get started here. First thing I'm going to do is click on File, and then I'm going to click New Python 3 Notebook. And what that's going to do is open up a new tab for us, and then it's going to give me something called a cell where I can do my Python programming. So just to show you guys how it kind of works, I can say print, and I can say hello here, and then I can go over here to the left and click on that button, and then it will print hello right under the cell. And then I can exit this print statement just by clicking on this X here to the left. Okay, now I can also create another cell. So I'm just going to click here in this cell here, and then click up on code, and then you see that another cell gets created. And so I'm going to write another print statement here, and I will just put world, okay, exclamation point, and then we can run that separately. And so now you see it just prints world. And if we want to run them both, I can just go to runtime here and click run all. And so now we see that ran both of these cells. And let's say that I'm done with this cell here. I can click on it and then go to these three dots to the right and click on that and then click delete cell. All right. So the other option, of course, is to just do all of your programming in one cell, which is also possible. Another thing that's kind of cool with this is you can basically change a few of your preferences. So I can change the runtime type, and we can use some. Let's go ahead and click on runtime type. We can use some of Google's hardware to train our models and things like that. So I could use a GPU or a TPU. So it's kind of cool that we have this available to us. But anyways, for now, I'm just going to keep it at its normal settings, and we're going to start predicting stock prices. So first thing we need to do is import our dependencies or install our dependencies. And one dependency I noticed that was not already installed on here. So in order for you to use that, you have to say pip install quando, and then you're just going to run it over here. And it's going to install quando for you. Now I already installed it on here, so it won't be installing this time. So it tells me that the requirement already satisfied. And that's because, again, I've already installed this. But if you haven't installed this before, you need to install it for this video, because that's one of the packages or libraries that we're going to be using for this video. All right. Um, I guess what I do is I say what we're going to be doing on this program, because I kind of like a note or a message telling what this program does. So this program predicts stock prices by using machine learning models. Okay. All right. Now let's go ahead and install our dependencies. So install the dependencies. Okay. And we're going to import Quandle. And we're going to import NumPy as NP. And then from sklearn, let's do a linear model for our machine learning. sklearn, of course, is a machine learning package, so it has a lot of the models that we will be using in this video. So we're going to import linear regression, and then the other machine learning algorithm that I'm going to use or model will be the support vector machine. And so from sklearn.svm for support vector machine, we're going to import something called the support vector regressor. So SVR for short. And then from sklearn model selection, we're going to import train underscore test underscore split. And this right here will be the method that we're going to use to split and train our data. All right, so let's go ahead and run this to make sure we got no errors. Excellent. And what I'm going to do is I'm going to go ahead and create a new cell just to just to split up my program and to make it look, nice. So now what we want to do is get the stock data. Okay, and to do that, I'm going to create a variable called df, and that's going to be short for data frame. And we're going to take, or we're going to use Quandl get method or function, and we're going to get data from Facebook. So you just say wiki/fb for Facebook. Okay, and then let's take a look. Let's say we're going to print the data. Actually, print. I say take a look. Take a look at the data. So we're just going to print it, and I'm only going to print a few rows of the data. So we just say df.head, and so if I run this, and that's why I said just take a look, because we're not going to see all of it. And so we can see a few columns here called open, high, low, adj.low, adj.close, and adj.volume. And adj stands for adjusted, so that's the adjusted low, the adjusted close price, and the adjusted volume. And we're going to use the adjusted close column here. All right, so let's go ahead and exit this print, exit that area. So I'm going to go ahead and I want to go ahead and create a new cell here. Okay, and we just want the adjusted close. So here I'm going to put get the adjusted close price. And to do that, I'm going to change our variable df, and I'm going to set it equal to df bracket adj dot close. All right, and then we can also take a look at that data. So here I'm going to say take a look at the new data, and we just will say print df.head now. So we'll see that it has changed. It should just have one column, the adjusted close column, and so that's what we see here. All right, so I'm going to X out of this, and let's go ahead and create a new cell. So I'm going to do another new cell here, and I'm going to create a variable for predicting out into the future. So what we want to do is we want to predict the future values of stock prices, and we need to know how many days out in the future do we want to predict. So I'm going to create a variable called forecast underscore out, and for now I'm going to set it to 1, but we're going to predict probably about 30 days out into the future. But I'll show you guys why I'm only doing 1 now, for now. So right now we're only predicting 1 day out in the future. So that's all I'm setting that variable to. And I guess I'll put a comment above it to make sure that if we look back later on this program, we know exactly what we were doing. So here I'm going to put a variable for predicting. I'm going to put end days out into the future. Okay, and right now our value n is equal to 1. Okay, so let's see here. In order to get that future prediction, we need another column, right? So right now we have something called our independent variable or variables. So the adjusted close will be our independent variable. And we need a target variable. That's what we want to predict, right? So I'm going to use something called the shift method to shift our data up and to create a, I'm going to create a new column. I'm going to call it prediction, and then we're going to shift values up from our adjusted close column, and that will be our prediction. We're going to shift it up the number of days that we want to predict into the future. So let me go ahead and show you guys exactly what I mean here. Okay, so here we're going to create another column, the target or dependent variable. All right, and oh, it's going to be shifted in units up. All right, so I'm going to create that new column now. So df bracket, and then we're going to say prediction. Okay, and I'm going to set it equal to our data set. Oh, df bracket, and then adj dot close. Okay, but it won't be, if I set it to this, it will be exactly the same as the data that we already have. And we don't want that. What we want to do is we want to shift this data. So I'm going to use that method called shift, and we want to shift it up. So we need to use a negative sign. And how many days do we want to shift it up, or how many rows do we want to shift this data up? And right now I'm just going to say 1. And then let's go ahead and print out this new data set. So the new data set. So I'm just going to say print df head. And let's go ahead and run this. Okay. So what we see here is that the original data only had one column, which was adjusted close. Now we've created a new column called prediction here. So that's where we did this. And this new data was created from the adjusted close data, but now it's shifted up one. So where we had 38.2318, if we want to predict the future by 1 day, we see that the next day is 34.03. And of course, that's exactly what we have here. And you'll notice the same trend going on. So if the day was here, 5/21/2012, and the adjusted close price was 34.03, the next day would be, the next day's price would be 31.0. And that's exactly what we see here and here. And then it keeps going on. So if the day was 31, I'm sorry, if the day's price was 31.0, the adjusted close price was 31.0, then tomorrow's price is going to be 32.0, because that's what we see here. And so that's all I did, was I moved up the values 1 day and put into this prediction column. So what does the end of the data look like, right? Well, let's take a look at that. So I'm just going to say tail. So df.tail. And what we can see is, okay, so for this day, yes, tomorrow's prediction is 152.19, and that's what we get here and here. But when it comes to the last day, we don't know what that value is yet. But so what it puts here is empty or not a number, and we will get rid of these values from our data set as we continue on. So let's change the shift to -2 as an example, and let's run this. And what we can see is that the data shifted up 2. So now for this day here, the adjusted close price is 159.39, and 2 days from now, the price will be 152.19, and that's exactly what we get here. And so you can see everything's just shifted up 2 days this time. So here the adjusted price is, the adjusted close price is 169.39, and 2 days from now it'll be 159.39, and that's exactly what we get here. All right. Okay, so last thing to do here, I want to be able to change this through a variable, and we already created a variable called forecast out, which tells us the number of days that we're going to forecast out. And so I'm going to place that here, forecast underscore out. And right now we set it equal to 1, so let's run this. And so again, we get what we originally had, where the data is just shifted up by 1 row or by 1 day. Okay, so I'm going to shift up this data by 30 days. And so let's run this. Okay, and I see a whole bunch of NaN values there. All right, so let's go ahead and continue. I think we understand that very well. And what we're going to do is go ahead and create a new cell. Okay, and here I want to create the independent data set, and we're going to call it X. Okay. All right, and to do that, first thing I'm going to do is convert the data frame to a NumPy array. And to do that, first I'm going to create my variable X and set it equal to np.array. So this will convert our data to an array. That's the method or function. And we're just going to say df dot, we're going to drop that new column that we call prediction, because we're going to be using the independent variables, or the independent variable, which is just adjusted close. So we no longer need that prediction column. So I'm going to drop it. So we just say drop, and what do we want to drop? We want to drop the prediction column. Okay. And next I want to remove the last 30, or really it's going to be the last n rows, right? Because n could be whatever value here. Maybe instead of n, I should say forecast out. I'll put n for now. I think that's understandable. So remove the last n rows, and to do that, all we have to do is just say X, and we're going to set it equal to, well, remember X now is a NumPy array, so we're going to set it equal to minus forecast underscore out. Okay. So for every column, we're going to get all of the rows except for the last 30 rows in this case, except for the last forecasted out rows. All right, so let's go ahead and print X. Okay, and so that's what we get now. You see that we don't have any NaNs at the bottom. So now we have created our new independent data set. All right, so let's go ahead and create a new cell. And here what we want to do is create the dependent data set. And so we're going to call it Y. All right. And to do that, we need to convert the data frame to a NumPy array. And this right here, of course, will give us all of the values, including the NaNs. Okay, so that means we're going to have to do some more manipulation on this data. But right now we're going to say Y is equal to, and again, Y is our dependent data set, and it's going to equal to np.array, because we're converting it to a NumPy array, and we are going to get the data from the prediction column, because we don't need the adjusted close column. And Yeah, that's fine. So we're just going to get the prediction. There we go. Make sure I spell it correctly, column. And I guess up top here, what I could have really did to make it a little bit easier, I could have just said df. Let's see here. I could have just said df adjusted close. And actually, let's go ahead and run that and see. Well, okay, it's a little different because, well, you'll see why. But for now, let's go ahead and put it back. So I'm not sure if you guys noticed the difference here, but one is a list and the other is a list of lists. All right, so let's go ahead and exit that for now. All right, and this is going to be a little different. So we're going to go ahead and continue here. Don't worry about that too much. So we're going to say prediction, and then I want all of the y value, all the values in our target column, except for the last 30 days. So now we want to get all of the y values except the last n rows. Okay, so to do that, we just say y equal to y, and then bracket, and then colon, and then minus forecast out. Okay, and again, that's because now y is a numpy array that we can do it like this. And let's go ahead and print y. And what you can see here is that, again, this is a list, right? So x is a list of lists and y is a list. All right, so we have our two data sets. Now let's see what we want to do. So now I'm going to go ahead and create a new cell, and we're going to split the data into 80% training and 20% testing. So I'll put that in the comments here. Split the data into 80% training and 20% testing. Okay, so to do that, we're going to use that function up top called train test split. And so I'll create my variables x train, x test, y train, and y test. And I got this from the documentation, the sklearn documentation, so you guys can read that as well to kind of see how I'm able to write this program. It's very good documentation. All right, so we're going to input our x data set and our y data set, and then we're going to tell it to the testing size, which will be 20% or 0.2. Okay, and now we're going to go ahead and run that. Okay, let's see. Train test split test underscore size is equal to 0.2. Let's see what I'm missing here. Equal to train underscore test underscore split. Okay, so what's the problem here? Not enough values to unpack. All right. So expected 5 and got 4. So why is that? Why did it expected 5 values, but it got 4? So do I have something extra? Yes. Yes, I do. Okay. So right here we had an X, and it should not be there. So let's go ahead and run this again. Excellent. All right. So let's create a new cell. Okay. So now we can finally create and train our model. So we're going to use the support vector algorithm. So we're going to create and train the support vector machine. And it's really the regressor, the support vector regressor. There's also a support vector classifier as well, but this is a regression problem. All right. And of course, regression is just a type of supervised learning problem. So we're going to use that function SVR or method SVR. But first, I'm going to create a variable called SVR underscore RBF and set it equal to SVR. And SVR requires a few parameters, so we need to give it a kernel. And I'm going to use a kernel called RBF, which stands for radio basis kernel. And don't worry about it for now. Then we need a parameter for our C, and I'm going to set it equal to 1E3. And then we need a parameter called gamma. And because I'm not really explaining what these parameters are for, I will be sure to put a link to the documentation that does. But just to make this video a little bit shorter, we're just going to go ahead and write it out like that for now. And so now we have created our support vector regressor. All right, now we need to train our model. So we just say SVR underscore RBF and then use dot fit. And we need to give it our training data. So we have X underscore train, and then we have Y underscore train. And so now this should train our model. But let's see, like I have something incorrect here. Let's see, train, X underscore train is not defined. That's why. So that X that I had up here was supposed to be X underscore train. So let's go ahead and run this here. And now let's go ahead and run this here. And so now we have X underscore train. All right. Okay, so let's go ahead and test how good our model is. So I'll do that in another cell. So testing model. We're going to use something called score, and score returns the coefficient of determination, R squared, of the prediction. The best, and I put this in another line here, just so you guys know, the best possible score is 1.0. All right, and so to do this, I'm going to create a variable called SVM for support vector machine underscore confidence. And I'm going to set this equal to SVR dot score of the X testing data set and the Y testing data set, a Y test data set. So let's go ahead and, let's go ahead and continue our program. We're going to print out the actual value. So I'm going to say SVM confidence, and then we're going to put the score, which is the SVM underscore, stored in SVM underscore confidence. All right, so let's go ahead and run this. And let's see where I messed up here. I misspelled confidence here. So let's go ahead and run this again. And let's see what else we got. SVM, let's see here. SVR is not defined. So that's because it's called SVR underscore RBF. And let's run this one more time. Okay, so now we get a nice confidence score. We get 0.9858, which is really close to 1, so that's pretty good. All right. And we haven't seen our predictions yet, but that's okay because I'm going to create one other model. So we're going to create a new cell here. And I'm just going to say create and train we're going to use a linear regression model. Okay, and to do that, all we have to do is create a variable and call it CLF for I don't know, classifier. Probably should be something like regress. Let's do a LR actually for linear regression, and we just say linear regression, and then we need to train it. So train the model, and to do that, I could just say LR dot fit. So fit, of course, stands for training. It's another way of saying training. And we're just going to put in our training data, which is x_train and y_train. And now let's go ahead and run this. Okay, excellent. So no errors. And now let's create a new cell, and we're going to test the model again, or test the linear regression model now. So I'm just going to copy that comment from up there using Control-C and paste it here using Control-V. And what I'm going to do is I'm going to actually I'm going to copy this whole thing. I'm going to copy this here as well and paste it here again using Control-V. And this time I'm just going to change this to LR instead of SVM, and I'm going to change this here to LR, and then we're going to change this here to LR and change this to LR. All right, and so now let's go ahead and run this, and you can see that we get 0.9816. So let's see which one seems to be better. Oops, it's right here. Run that. So it looks like the support vector regressor is better than our linear regression model. All right, so now let's go ahead and create the values that we want to forecast on. So I'm going to create a new cell, and here we're going to set a variable. We're going to call it x_forecast equal to the last 30 rows of the original data set from the adjusted what was it called, adjusted close price. So from the adjusted close column. All right, and again, so I'm going to say x_forecast, and we're going to make it a array, a numpy array. So np.array, and we're going to drop that predictions column. So df.drop, what do we want to drop is prediction, because that's still in our original data set. It's the prediction column in the adjusted close column. All right, so there we go. And let's see, because this is a numpy array, I can use the bracket here, and I just want all of the rows. I only want the last 30 rows actually. So I can just say minus forecast out is what our variable name was, and then colon. So now to give me the last 30 rows from all of the columns in this set, which is just adjusted close. So I'm going to go ahead and run that. Okay, and maybe we can print it out as well just to kind of see what it looks like. Forecast. So x_forecast, let's print it out. And so now we see the last 30 rows of our data. Okay. All right, so this is the data that we're going to do our prediction on. So I'm going to create a new cell, and now it's time to actually take a look at the prediction. So we're going to print the predictions for the next n days, where n in this case is 30, right? So I'm just going to create a variable called LR_prediction, and I'm going to set that equal to LR.predict. And what are we predicting? The x_forecast. All right, and let's go ahead and print that. So we're going to print LR_prediction. All right, so run that. And then let's do the same thing for the support vector machine. So we did that for the linear regression model. So maybe here I put print linear regression model predictions for the next 30 days. And I'm just going to copy this and paste it here. And now we're going to print the support vector regressor model, and let's see what we called it again is SVR underscore RBF. So I'm going to change this to SVM, and we're going to get it from SVR underscore RBF. And then we're going to change this here now to SVM. Okay, and now let's run this. And so we see that we printed first the last 30 days of what the linear regression model thinks the price will be for the next 30 days. I'm not sure if I said that or not. For the next 30 days of what the linear regression model thinks the prices will be based off of our X forecast data. And then here is what the model thinks thinks what the adjusted close price will be for the next 30 days from our support vector regressor. All right. So now we're predicting the stock prices in the future. All right. So these are what we think the prices will be 30 days from now. And then of course you can go ahead and start making money. Just bet on whatever stock you want to. Now what I can do here is I can change the data that we use. So instead of FB, which is Facebook, we can just simply change this to something like Amazon. So I can say AMZN, and then we can run this whole thing. So just click run all. And this is how simple it is to reuse this program just to see um, how we can use it for different stocks. So where is the confidence for the model? Okay, so here it looks like the SVM model only got a score of 0.9317, which is still pretty decent, but this time it looks like our linear regression model is a little bit better. We got 0.9888. And of course, we should use other metrics as well to kind of see how well our model's doing. Right now, this is just a simple program. So you probably won't get rich from this program, but it's still pretty neat to see this. And so now you see something's going on here. It looks like, oh no, everything looks good there. Oh, until we get, okay, here, it looks like the numbers seem to be repeating for some reason with the support vector machine model or support vector regressor model. And above here is our linear regression model and the values that it thinks the stock price will be in the next 30 days. So now what we want to do is we want to save our file. So I'm going to zoom out here, and I'm going to click on File, and then we can save it as a .py file or a .ipynb file. So this right here is a Python notebook file, and then the other is just a Python file. And then once you save it, you can run it wherever you want to. You can run it here. It's going to be saved on this site here, so you don't have to worry about that. And that's basically it. So thank you guys for watching, and leave any questions you have in the comment section. Don't forget to hit that like button and that subscribe button. And if you found this video helpful, please share it. And as always, guys, thanks for watching, and go ahead and get out there and start making some money with your new machine learning program, Python program that can predict stock prices. So again, thank you guys for watching, and I'll see you all in the next video.